and opening my presentation. So you can see the slides, right?
Yes.
Yeah. Thank you. Okay.
Yes.
So dear colleagues, yeah, it's nice to have you here today at this seminar. And today we are presenting our actually something new that we made with Vlado during the summer. So this presentation was done for Sunbelt Virtual Conference, and you can even see the Sunbelt's logo on the left. So we never presented this in the lab, so that's why we decided that it can be interesting also to discuss it here. So the idea is the comparing of two approaches to bibliographic network construction. So probably you read the abstract and you have some understanding of what we are going to tell. So the research question is motivated by the fact that there are two opposite strategies for bibliographic network production. And one of these strategies is based on the very time-consuming and very extensive procedures of cleaning and working with data. So before making an analysis, we have to work a lot with data. We have to change a lot. We have to check a lot of things. So this is the first strategy. And the second strategy is is based on the so-called believe in statistics approach. So we think that we do not need to work so much on the data cleaning of the whole data set, because we believe that all important things will anyway pop up and we will see them. However, if there are some minor errors or some problems with some data entities, it will not appear in the results. And so basically we check important units, which we identify during the preliminary data analysis. And based on this, if we see that there are some problems with these units, we also make some changes for them, but not for the whole data set. And then the question arises, if these both approaches are given the same or very similar results, or they give different results. And if they're different, what are the differences? And we can answer to this question if we have data sets on the same topic, which are constructed in both ways by this fully cleaning of data set strategy and the strategy of this believe in statistics approach. So this presentation today is devoted to the comparison of the results that we can get using these two approaches. And I didn't say it from the beginning, but if you will have some questions, I think that you can interrupt me and ask, interrupt when at some stage of my presentation and ask the questions so that we will clarify some things which are not very well said. But also we can discuss it at the beginning, at the end of the presentation. So we could compare these two strategies having two data sets. And hopefully we found such data sets. One of them is the one which is constructed by Vlado and me, that the data set on the literature and social network analysis. And this is the data set that we use in the analysis of social, the field of social networks. Social network analysis, and probably you, some of the lab members already read or have seen the presentations of the results which we get for the analysis of this data set. So these are almost 71,000 of bibliographical records from Web of Science, and the data set is up to 2018. And as you already see, this is done in the second strategy of data collection, and it required mostly automatic data cleaning procedures. As the example of the first strategy, we used the data set on the literature in social network science, which is collected by high collates. These are almost 26,000 of bibliographical records, and also they're from Web of Science. However, they are collected up to 2012. And this is actually, the whole data set is the base for the PhD project of high collates. So that's why he had something to do for a lot, I would say several years. And the whole paper which we found is devoted exactly to the procedures of cleaning the data and the entities disambiguation. So he really put a lot of efforts in this data set construction. And the queries for these two data sets are quite similar, as you can see from the keywords which are presented on the slide here. So they're based on social and network or networks keywords. And I need to say that for the case of high collates, the data construction also is also quite comprehensive. However, in our search, we also used the so-called saturation search for missing descriptions. So we did not only collect the data for these two keywords, but also top-cited papers, which had more than 150 citations, which were only which didn't have full descriptions in our data set. So we did it manually. Then we also collected the data from the flagship SNA journals, which are indexed in Web of Science, and also the papers of the most prominent authors, and there were about 100 authors. So we had a little bit different strategies, but we can say that for two of these data sets, the search was quite, let's say, comprehensive, and it included a lot of data on what we were searching for on social network analysis. We constructed the parallel data sets, and we had to stop at 2012 because the data set of high collates was up to this year. And here on the slide, you can see the number of works, authors, and keywords and that we have in these data sets, and also the time coverage. Here, I should say that it is important that so we call the data set of leads SNS, Social Network Science, and we call our data set Social Network Analysis, SMA. Why we have two columns of SNS? It is because we had in original SNS dataset, the keywords were especially constructed in such a way that they were the sequences of words. So they were keywords phrases. So, for example, social network analysis was one keyword. In our case, we split these keywords, and we have social network and analysis as separate keywords, which are, however, connected to each other. So this will be a triangle. So that's why, to be able to compare the keywords analysis to our data set, we split the keywords in SNS1 dataset to SNS2 dataset. So instead of 23,000 of these phrases in SNS2, we have almost 9,000 of keywords which are not phrases anymore. They are just singular keywords. And you can also see. Yes.
Can I ask you, so these lists gave you the data set so that you could work on it?
Yeah, this is published.
Okay.
Yeah, we found it. This is completely open and published in internet so that we could work with it. And you can also see that the time coverage is a little bit different. However, it starts in the beginning of the 20th century for Leeds data and at the end of the 19th century for our data set. Then we had similar data sets, and we could construct similar networks out of these data sets. So both of them included networks of works and authors and works and keywords. So the work and all the associated authors who were writing it, and also all the keywords which are used as keywords by the authors. And also we had the partition year for each work. And this meant that these networks share the same set of works and they're linked, and that's why we can construct the derived networks out of these two-mode networks. We can construct one-mode networks. These are the one-mode network of collaboration and keywords concurrence. There are different types of collaboration networks that we can construct, and I will have the work which describes it very precisely, which is cited here. I will have it in bibliography. But the basic idea is that one type of this collaboration network is based only on the number of papers that two authors wrote together. This is good, this is interesting and can give us some result. However, it is very important to take into account the number of works that author has and the input of this author to the collaboration with others, because some authors prefer to write mostly by themselves. Some authors collaborate a lot. And so to be able to also look at these patterns, we also constructed other normalized networks, which are called here on the slide second collaboration network, which shows the collaborativeness in the index of the author. So how collaborative he or she is, how he or she is inclined to work with someone else. And also the so-called forced collaboration network. This is the network which uses Newman normalization, the normalization which was proposed by Mark Newman in one of his papers, who actually proposed that if we look at the collaboration between authors, then we should not take into account cases when they write papers only by themselves without anyone else, because then it's not collaboration. So we constructed these types of collaboration networks, and also two types of keywords concurrence networks, which is one is based on the number of times when two keywords are used together, like social and network and analysis. And another is another also takes into account the normalization, and so that's why this count the fractional contributions of different keywords. So this is especially done to minimize the input of the keywords which are used very frequently. So we had this types of networks, and we made some analysis of them, which allowed us to see if the results for these different data sets will be different or not. So first of all, let's look at the sizes of networks. I think I also told about it, and you've noticed that in our data set in SNA, in the whole data set, we have nearly 72,000 of works. When we cut up to 2012, we have 27,000. And in Liet's data set, we have almost 26,000 of works. So this is quite similar. This is the numbers of authors are also quite similar, let's say. So these are 46 and 41,000 of authors. And you can see the number of arcs is also quite similar. For works and keywords, this is a bit different. As I told that we had to split these phrases in SNS1 into separate keywords. So then it appeared that we had about 9,000 keywords, and in our data set we have almost 18,000. So this is almost twice more. Now let's look at the degrees of the degrees distribution for distributions for these networks. So this is the network of works and authors, and we can see in degree distribution, which is the number of works that author wrote, and the out degree distribution, which is the number of authors per work. So here we can, these two upper pictures are for these are distributions in logarithmic scale. And here down we can also see the probability distribution. So we counted the frequencies to total number of total sums of the number of works and authors. I'm not sure if you can see from the screen. However, I should say that these distributions, we can see the very similar trends in these distributions, even though there are some differences in the number, in exact numbers, but the whole trend is quite similar. Then let's look at the degrees for VK network. So this is the in-degree distribution number of works, which I described by keywords, a keyword, and also the distribution on logarithmic scale, and the probability distribution, and the three data set that we have, SNA, SNS1, and SNS2. Basically, again, we can see some minor differences, but the whole distribution shows that the trends are quite the same. So we have similar patterns. And then also the annual distributions of publications. And here we see, we have the works per year, starting from the beginning of the 20th century. And then we have works per year in logarithmic scale, and also the probability distribution. And what is interesting, that again, the number of works is distributed in a very similar way, and we can also see, notice that there is almost a line. So this, we can say that there is an exponential growth of the number of publications in the topic of social networks and all the related things, starting from the 1960s, which was already shown by the previous analysis. On this slide, we present the annual number of authors. So here, on the left, it is the picture for SNA dataset, and on the right for SNS dataset. And here we can see the shares of papers which are written by 1, 2, 3, 4, and more authors. So talking about collaboration in the field, we can see that the collaboration is developing. So the level, so the number, the shares of papers which are written by single authors decreased significantly. So it was for one data set, it was about 70% in the 1980s, and up to 2010, 2018, it became about 20%. And in this Leeds data set also we had about 60%, and now it is about 20%. So the field, the authors are becoming more collaborative. Also, the number of papers which are written by 2 authors, this is this blue line, this is basically remains the same. It is about 20–30% in different time points. And also we can see that the shares of papers written by 3, 4, 5, 6, and more authors is increasing, especially in recent time after 2000s. And as we already proposed before, it is connected to the fact that there are many authors from new disciplines who came to the field. For example, from biology or physics and economics, medicine. So that's why they can have different strategies and different norms of including the authors to the paper. So that's why it can also be the influence of that part of authors. Then we decided to look at some of the top units. So top authors are presented on this slide, and these are the authors who has the largest number of works. So this is the first column. Then their total contribution to the field is shown, and also the collaborativeness index, which I was talking about before. So this is from this second collaboration network. And it's interesting that for 2 data sets, actually the top authors are very similar. I don't know how much it is seen, but the authors who are the same in 2 data sets, they are shown in bold. So you see that almost 2 lists are almost bold, marked in bold. And we should notice that in our data set SMA, we have more works for these authors. So you see that for Latkin we have 82 works, and here we have 74, and then not more than 50 works. And in our case we have 79, 62, 60. So we guess that this is the result of our saturation search, which was very productive, so that we have a lot of works by these authors. And then we can see the total contribution of these authors, which is also quite similar, and also some of the collaborativeness indices are exactly the same. For example, for Latkin, we have 74% in both cases. However, of course, there are some differences, but they are not so, let's say, crucial. So anyway, the obtained results are very similar. Then we look at the top keywords. So these are the loops from the network of keywords called currents, which is not normalized. So this is the number of times how much the keyword was used in the dataset. And so you can see how the phrases you can see that in SNS1, the phrases were used like social network analysis, social capital, social support, social interaction, network structure. So in the case of SNS2 and SNA, these phrases were split into single words. So that's why it is, of course, difficult and not possible to compare the top keywords from these two data sets to the keywords which we have in this original one. However, we see that still there are some common words like community, web, and probably the topics are very similar. However, if we look at the this SNS2 and SNA datasets, again, we see some intersections, and of course, social network analysis are the top keywords, but of course, we could expect it, and it just shows us that the like we have the relevant data sets for the topic that we study. But there are some other words like community, structure, information, support, model, communication, online, knowledge. So in some sense, they also look similar. However, there are some other keywords which are not the same into lists. Then we looked at some networks substructures. Here on this slide, we have their co-authors groups, and this is from SNS dataset from Leeds, and these are the authors who have minimum 10 publications written together. As I told, so this is the collaboration network, which is based on the number of works that two authors have with each other. Probably it's not very well seen, and we really need some time just to go deeper, but I will show you the next slide, and then some summation of this information which is shown here. So again, these are the co-authors, but based on the analysis of SNA dataset. And so again, we can see some names. Actually, the names are quite known. For example, here now you can see Bargati and Everett, who have 26 works written together. And for example, Latkin, who was seen as the one with the largest number of works written. And then we just looked at the intersections of these groups. So here you can see the groups which are exactly the same or quite the same in two data sets. So there are 20 groups. And I guess that while looking at the slide, you can extract some of the names that you know, very well known ones. However, also there are some groups of authors which are unique to each data set. So this is for SNS data set on the left, and for SNA data set on the right. So for example, here in our data set, we extracted the group of Vlado, Anushka, and Patrick Dorian, who are working a lot with each other. Then we wanted to look at the substructures which are called islands. So there is a so-called islands approach, and you can also, I think I have some links to it in the bibliography. So these are the locally connected components of the nodes, which are more connected to each other than to the whole to other nodes in the network. And using this approach, we can say that we want to extract the groups which are of size and we can tell which is the range of this component should be. So we wanted these islands to be from 5 to 100 nodes, and we applied this approach to the fourth collaboration network, which is this Newman collaboration network. So this is the true collaboration, let's say. And for the two data sets, we got 2,000 islands, and for SNA, 1,400 islands. And also the distribution is shown here. So the whole pattern is quite similar, let's say. And the same is for keywords concurrence islands. Here we wanted islands to be from 2 to 100. And so we applied this algorithm to 3 data sets, to SNS1, SNS2, and SNA. And we can see that we got different total number of islands and number of nodes that are included to these islands. However, in each case, there was the main component of either 100 or 99 islands. And there were a lot of islands of the sizes 2 and 3, and especially it was the case for SNS1 dataset when we had very particular phrases instead of single keywords. So it was quite, there were quite a lot of pairs of keywords. Now we have some visualizations of these islands, main islands that we constructed. So this is for SNS1, and I will make some zoom for some of the topics that you can see. But again, then I will summarize so that we will have the impression of what the topics of these substructures are. So we have something about users, Facebook, online social networks, internet, then community and social capital, social structure and social support, and friends and social relationships. So this is something which is in the middle of the network. This is the substructure for SNS2 dataset, and we had to remove social and network from this substructure because then everything was just very much connected to these two words. And so we also have community, user, web, analysis, structure, support as the parts, as the nodes which have high in degree. And this will be the structure for SNA dataset, also the main island, and again, community, model, small world. So basically, I can share this presentation afterwards, and you can look more precisely what is inside. However, as I told, we made some summation of the topics which we found in the substructures. And so these are the topics on social support, health, well-being. So we have the words like family, friend, trust, social ties, older, adults, disease, so something like this. Then the topic on social capital and trust. However, we have seen this topic very well when it was in the SNS1 dataset, because these phrases, they were showing that this is social capital, human capital, trust, Putnam, and so on. So this is the famous Putnam theory about social capital. However, when we split the keywords, then it a little bit blurred in the results. So we still have the words capital, human, theory, game, cooperation, for example, for SNS2, and capital, community, trust, model for SNA. However, it's not exactly the part of the subnetwork. So it's somehow blurred. Then we have the topic of community as a structure. So this is online community, internet, virtual, so something connected to the structural characteristics of community. And then community as a community detection algorithm, which is proposed by the representatives of network science. So this is community detection, complex networks, small world, model, large scale, free. So these are the keywords which are associated with the works of, for example, Mark Newman or Albert Barabashi, and so on. Then we have the topic of SNA as an approach, where we have such keywords as social structure, social science, network approach, PIC, centrality, so some measures which are used in network analysis. Then social networking sites and social media. So this is all about Facebook, users, Twitter, media, service, web 2.0, and so on. And then information and knowledge management. So this is about data mining, web management, information, data retrieval, and so on. So these are the topics which we could extract from these main components of our networks. So I am already at conclusions. So as I promised. So just to sum up, we can say that so we have shown different distributions of 3 data sets. So exactly we looked at the numbers of works that author wrote, authors per work, works described by keyword, and annual distributions of publication, number of authors. And we basically see that they follow similar trends. However, of course, there can be some variations, and which are connected to the different number of bibliographic units in our regional networks. Also, we've seen that top identified authors are very similar, and top keywords are partly similar for SNS2 and SNA dataset, but different from the SNS1 dataset, but we already explained why it happens because of these phrases. And the substructures of authors are highly intersected, and I would say that I was even surprised how much. So also the same can be seen, can be said also about the keywords which are extracted for 3 data sets, and also they can be assigned to the set of the same topics. So we didn't see in this main components, we didn't see something exactly different, something that exists only in one data set. We can say that on the level of the structure comparison and in identification of the top parts of the networks, the 2 approaches lead to quite similar results. However, of course, we can suppose that if we go deeper with the analysis and comparison, there would be some differences which are not found now, but just this look from like upper, from up, we can see that there are a lot of similarities between the results. And that's why we actually recommend that if we are interested in the analysis of some kind of such data, we recommend the use of our approach, so which is this belief in statistics approach. However, so this is much less time consuming, and with this approach we can get quite similar results. So we do not need to spend, I don't know, several years before we can start the analysis. However, of course, it is important to consider that when we deal with bibliographic networks, we should take into account that we should not just take the data and work with it without any cleaning, any data disambiguation procedures, so without anything. We would say that we recommend to have the strategy which would also take into account some cleaning of some of the important components of the networks, of the data. So I think this is pretty much it. Thank you very much for your attention. And here we have the bibliography list, and yeah, I guess that so this is the link to Liet's dataset, and our dataset is well described in this paper, which is on the number 4. So if you have any questions, we are here.
Well, maybe.
Thank you, Dasha. I don't have questions. I just want to say thank you before I will have to leave in a couple of minutes.
Mm-hmm.
Maybe I have also a question. I think it would be wonderful to see also the analysis of citations. For instance, main path, and do you get the same main path in both in S2 and SNA? That would be interesting to see. Nevertheless, you added earlier works into your data set. Maybe that could disturb the main path. But I would love to see the comparison about main paths.
Mm-hmm. Thank you very much. But Vlada, probably this information is not
available.
There is no this information on citations, right?
The citation network is not available.
Not available.
For the other network.
Yeah.
Mm-hmm.
Ah, I see.
Mm-hmm.
Okay. Okay. Mm-hmm. I'm quite surprised that after so much cleaning, the size of the network is actually pretty comparable. So I would assume that with so much cleaning, they would lose some works, but the sizes are very, very similar.
I think one difference between both data sets is that maybe in our data set we didn't put the keyword the query network science, and maybe leads was more searching also in that direction. So in this sense, I think that there are some more data about data science. And in our data set, because of our saturation phase, we produced more works which were added manually on social network analysis. So there are some slight differences, but in principle, both data sets are almost pretty close one to the other.
Surprisingly, yes, very good.
Yes, and even if you look at these top authors to the number of works that top authors have, so we have, for example, in Liet's dataset, so we have 48 and 46 works for Barabash and Newman. But if you look at our dataset, we have even more for Newman and Barabashi.
Yeah,
So,
but this is because of the saturation phase. They popped up because they are important. In the preliminary analysis, we detected them, and then we searched for that papers and included them into the network.
Yeah, I just mean that in sense of the representation of network science, so we should also say that we have quite a good representation of the representatives.
Dasha, go back to the queries at the beginning. So it seems to me that, so you don't have analysis and they don't have science. You both have network, social network. So,
yeah, but also in the paper of Litz, the procedure how to collect the data is quite complicated.
Yes.
So you need to, it's quite a complicated procedure. So you find some, let us say, seed papers, and from that seed papers you detect new papers and so on. So it's quite complicated procedures. I don't remember the details now, but so
from that,
very time consuming, a lot of manual work.
Yes, I could not show it on the slide, but I think there are a lot of pages devoted to this step of the data collection.
Well, but it is pretty clean, pretty clear that the approach that you and Vlado took is very comparable. So you don't need all those complications. Yeah, very good, very good. I like it. Very good.
Thank you.
I must say that we also spent a lot of time in cleaning, and this saturation process also takes a lot of time. So it's how to say, essentially the largest part of the analysis was essentially collecting and cleaning the data.
Yeah, but what kind of cleaning? This is
are
probably different kind of cleaning.
The first thing is you have one of the biggest problems in textual data is the identification of units, which because, for instance, the same person can have different names, and this disambiguation process is very time consuming. And also, for instance, journals. Journals appear under, let us say, 5, 6, or 7 different names and so on. And you have then to identify the right. But here we don't have journals in this case.
But did they also do the same, this kind of cleaning that you did?
Yes, yes.
They did the same?
Yeah, approximately the same.
Okay. So one part of cleaning was similar.
Yeah, essentially, the goal is the same. You want to identify the units. It means keywords, authors, journals, and so on. Yeah? Works.
However,
maybe if you were,
sorry.
Maybe if you are going to write a paper of this, I think it would be good to describe what kind of cleaning was done in both and what kind of cleaning was done only in their approach, or at least type of cleaning, so that the reader can somehow see that actually some kind of cleaning was needed in both strategies.
No, we already published, and Litz also published his procedure. So, and in both cases, it takes quite some pages to explain everything. So,
yeah, but roughly, I think roughly you have to say that.
yes, but in, let us say, some paragraphs.
Not in very big detail, but
Yeah.
But at least something which was similar cleaning and what they did more, which looks like is not so important because the results are so similar. Yeah.
However, we still have not decided the problem of authors disambiguation. So we had to remove the Chinese authors from the results.
And what about they? Did they remove Chinese?
I don't think so. I think they tried to identify them. However, as we can see the results, so these Chinese and Korean names, they do not appear among the top authors. So it means that if we do not take them into account, so then it's not such a huge problem. However,
but it depends, because maybe in year 2012 they are not yet so active, but nowadays maybe Chinese are becoming quite important. So this is a big problem.
Well, but they have a name, and this name is used for different people. So if they would have Chinese, so some Chinese are then very, very frequent. So maybe they did something because the Chinese didn't come up in the top. Yeah. So maybe they also did something on it. Which will be a problem always with these Chinese names.
It would be nice to have some IDs for the authors, so then there would not be any problems at all. If each author would have his or her own ID. Actually, the authors do have them, but we do not have this information in data in our base.
Yeah. Yes. Well, very nice talk, but it looks like only our triad is talking. Maybe we should shut up and to give the word to the others.
Yeah, dear colleagues, if you have some comments or questions or just something to say, so please, it would be nice. Because I guess that we, three of us have presented, I mean, we've seen this presentation also at Sunbelt, so we could imagine what would be here. Actually, I have a question that, do you think that according to these results, it can be something which can be written as a paper? So will it be interesting?
I'm sure it is interesting. I'm quite sure about it. Actually, we didn't immediately compare it, but when we were studying this peer review, there was also a group that was that have the same strategy as Leeds, and we did in such a way as you did. We did not compare it very, very strictly, but it also appeared that our approach was pretty good. So, and that all errors and so on somehow disappear when you are analyzing. If you are doing, I don't know, main islands or top researchers or something like that, all those mistakes are below, they're down. So, but we never wrote a paper about it. So I think it would be very nice, also for practitioners, that they don't need to do this horrible work, and that, so, but I think you have to at least somehow describe the cleaning that you did and what they did, so that the reader will be, because they will not go to read previous papers of you and previous papers of Leeds I think you have to write here, not in detail, but at least somehow. But I think it would be a nice paper. And what is your title, Dasha?
Yeah.
What's the title of this? Go up.
Comparing to approaches to bibliography.
Comparing to approaches to bibliography. Yeah. Yes. And I'm sure Scientometrics would be very, very happy to have this kind of study published, because this is very important. You know, this is a very important study. Mm-hmm.
Okay, thank you very much. So then we have something else to work.
It's a pity that they didn't publish the citation network or the data about it. So that's a pity.
Mm-hmm.
Yeah.
But we should search probably. I don't remember so much, but now this paper is published, so we can actually ask the authors, I mean the leads, about this type of data. So then it would be interesting to add.
Yeah. But also this is okay, you know, so because it would be maybe too long if you would add also citations. So I think that, and I would not take only top 10, for instance, authors. I would take top 20 or something in the paper, so that, and then probably the overlap would be even higher, I'm sure. Yeah, keep going.
Okay.
Yeah, one thing is, I was trying to find some measure to compare the distributions in one network and the other. So if you look to that,
you could make just Spearman correlation coefficient.
Yeah, the problem, yeah, for instance, one of these, if you look, they are not very different, but how to say, it's the problem is that here we have log scales, but if you take the traditional measures of a difference of distributions, it turns out that essentially the differences are very large. For instance, if you take Kolmogorov-Smirnov or something like that, then you are comparing essentially this value with this value, and these values are, the difference are enormous. Although if you go into logarithmic, it's the difference are smaller, and so I think that there is a problem in these comparisons when you are comparing quantities that have very large values and very small values, because how to say, if you go to the other picture,
This is for
maybe,
publication.
yeah. So the difference here are because you have a logarithmic scale here. So the difference here are between, let us say, relatively small numbers, and on the if you go to this part, it seems that they are very close, but essentially the real values are very large. So the differences are very large. So I'm searching for some statistical measure for measuring let us say, closeness or difference between two distributions, which are in some sense appropriate for such distributions as these ones are.
But it looks like that the red points are always a bit lower than the blue ones, right?
Yes, but in some, but if you look here on this picture, I think we have. Can you show this one also?
What? We don't.
The third one, the third picture.
You mean closer?
Yeah, this one. Yeah.
Mm-hmm.
I have my so yeah, here for instance, if you look to this one, yeah, if you look to this one, then here we have a probability distribution, and this means that we divided the values, the frequencies, with the sum of all frequencies. So essentially, in both cases, we get the sum of the corresponding values equals to 1, because it's a probability distribution. But because on the y-axis we have a logarithmic scale, then the top, these red dots that are in the upper right corner essentially are much larger than the corresponding. So how to say, it's this picture is somehow yeah, we have the logarithmic transformation, and so now if you're comparing this, it has the effects on different sides. So, but in some sense, we can say that this, let us say, blue curve and red curve are pretty close in some sense.
Yeah, but if you forget
I don't know how to find. I would like to find some statistics that can measure this, and so that we can say that.
Yeah, how different or how similar exactly these distributions are.
Mm-hmm.
one possibility is that you make linear trend and you take the slope, and it looks like that the slope is higher for the reds than for the blue. But is that significantly different or not? And that you can test, actually.
Mm-hmm.
Yeah. No, but I think if you take, let us say, I would forget the SNS one. I would take just 2, because then it's comparable.
Mm-hmm.
And then I would make, for instance, if I make top 20 or even more, top, I don't know, it can be made also top 100 or something.
No, it's too much.
Or I don't know.
Maybe we can do top 100 and then look, maybe take top 20 and then report also for the missing, where they appear in the let us say top 100 list.
Yeah, and the ones that are there, I would make Spearman correlation, because then you would see are the same ones on the top and the same ones on the bottom. So you just take the intercept, and you have to say which ones are taken out, and then I would make Spearman.
Mm-hmm.
And for the keywords, I would make the same.
Mm-hmm. Mm-hmm.
Yeah, but well.
Okay. A lot of work to be done. A lot of work to be done. Yeah.
Not too much, I think. Okay.
Okay, so it seems that we do not have any other comments and questions, but I will, so I recorded this presentation, and so then it will be, probably someone will look and ask us something else. Let's see.
Hello to everyone. I see Toma, Rustam, Gregory, Polina. So
And
nice.
Ilya Karpov is also here.
Ilya, okay.
Mm-hmm.
Hello to everyone.
Yes, it's nice to see you.
Hello.
Okay, so I will stop the demonstration and the recording, I think. So thank you very much, all who have been here.
Bye.
Yeah. So Nyusha and Vlada, we will be really happy to see you in our at our other seminars. So we will make a plan. It is already almost done. So we will send you so that you will know in advance when we are planning to have this English speaking seminars, so that you will join us. Yeah. Okay. Have a good evening, everyone. Thank you very much.
Bye.
Goodbye.
Bye.
Mm-hmm.